Okay, the focus of today's lesson is solving. And so we're going to look at how to solve equations because as we move on to our main goal, which is to graph some equations that look like this, solving is going to be important to us in order to be able to find the intercepts. So if you guys remember adding and subtracting rational expressions, I did some stuff on it during voluntary enrichment, or you did it in Algebra 2 Trig. When you had these fractions, you worked on finding the least common denominator in order to add the fractions together. We are going to use the least common denominator, but in a different way. So it's going to remind you of, like, I don't know if you guys called it like fraction busting or stuff like that you did in Algebra 1. So let's say I had an equation like this and I really didn't like dealing with fractions. Then remember, I have the freedom to multiply both sides of the equation by anything that I want, as long as it's the same value being used on both sides. And what I would want to do is strategically choose a value that when it's multiplied with these fractions, it will cancel out the denominator in the fractions. Okay, so when I look at my fractions, this one has a 3, a 5, and a 4. None of those have any common factors. So whatever I multiply by, it needs to have a 3 to cancel out the 3, a 5 to cancel out the 5, and a 4 to cancel out the 4. That's 60. So I would want my least common denominator to be 60. When I multiply both sides of this fraction by 60, you'll see that when 60 multiplies 1/3 x, when 60 multiplies 1/5, and when 60 multiplies 3/4, I should have a new equation that has no fractions left in it. So notice the 3 can go into the 60 20 times here. So I'd have 20x. 5 can go into 60 18 times here. Not 18, I apologize. 5 is 12 times. And 4 goes into 60 15 times. So now you see you have a much simpler equation to deal with. So we want to do this exact same thing. The problem is it's not all going to be numerical. Okay, so we're going to have to look beyond the numbers at the algebra expressions. So we're going to focus on example 1, the algebra expressions there. So first notice this is y plus 2. That's one factor. I can't break it down. This is a factor of 15. That means it has a factor of 3 and 5 embedded in it. And 3y plus 6 can be factored. A 3 can be removed from each of the things there. And it can have y plus 2. And that's good. If you use too many factors, you guys will come up with something that's not solvable. So it's really good that we see these common things of y plus 2 here. Okay. So what does this mean? If I was going to make a least common denominator for these fractions, something my denominator would have to have is y plus 2. So I want a factor of y plus 2. When I look at the next denominator, it has 15. 15's not going to cancel out with y plus 2, so I'm also going to need a 15. Just like over here, how since 3 and 5 and 4 had nothing in common, I had to use each of them in my LCD. I'm using the same thing here. When I look at the third denominator, it has two different things, a factor of 3. Now you might not see a 3 here, but remember 15 contains a 3 and a 5, so there is a 3 there. Okay, so we don't need to repeat the 3. It also needs a factor of y plus 2, and again we already have that here, so we don't need to repeat that. So the LCD, the thing I'm going to choose to multiply both sides by, is going to be a factor of 15 times y plus 2. So I'm going to take my entire equation and I'm going to choose to multiply the entire left side by 15 and y plus 2. And that's totally fine as long as I do the same thing on the other side. So think about what that means when we write it out. There were two fractions on the left side. This quantity that you've chosen to multiply here distributes to each of those. So I used to have a 3 over y plus 2. That's now being multiplied by a 15 and a y plus 2 with nothing in the denominator. Then there was an addition sign. I used to have a 7 over 15. That's now being multiplied by a 15 and a y plus 2. Nothing in the denominator. On the right side, I had a 23 over a 3 times y plus 2. and that's now being multiplied by a 15 and a y plus 2, nothing in the denominator. And I'm going to hope that this simplifies, and this simplifies into something that's easier for me to solve. Okay, so when I say simplify, remember we're looking for factors. This is why we worked on simplifying last week. We're looking for factors in the numerator that simplify with factors in the denominator. So in this first group, y plus 2 is a factor I can cancel out of both the numerator and denominator, and I'm left with a 3 times 15. In the second group, the factors of 15 can cancel out, and I'm left with a plus and a 7 times y plus 2. On the right side of the equation, the y plus 2's can cancel out. A factor of 3 can go into 15 with a leftover factor of 5. So on this side, I'm left with 23 times 5. So the equation I'm left with can be better written as 45 plus 7y plus 14 is equal to 115. And then I'm just going to work on solving from here. So 7y plus the 14 and the 45 can add together to make 59. Then if I subtract 59 from both sides, I'm going to get 56. And now that I have 7y equals 56, if I divide both sides by 7, I will have y is equal to 8. Okay? Before you put a box around that 8, you need to check for extraneous solutions. So the question is, do we have extraneous solutions? Extraneous solutions are answers that you did nothing wrong on. So all your algebra here could be perfect and right. But if you plug them back into the original equation, so you're checking the original equation, they make something that's undefined. Okay? You're checking the original equation for something undefined. Specifically for you guys, since these equations have fractions, undefined would mean making 0 in the denominator. So that's what we don't want. So you could plug it in and check the whole thing, but really you just have to focus on these places where y was. Look what was happening with y. Y was being added plus 2. If you plug in 8 for the y in the y plus 2, oops, there's a 3 on top, you would get a 10 in the denominator. You just want to make sure that that's not 0. As long as you're not getting 0 in the denominator, it's good. So here y equal to 8 is good because it doesn't make a 0 in any of our denominators. So let's look at example 2. In example 2, again, we're going to focus on the least common denominator. Now, this denominator has already been factored for us, so we're going to go through. So least common denominator here. Scoot it over a little bit. In the first fraction, my denominator contains a factor of 3 and a factor of x minus 2. So I want to include all of that as part of something I'd want in the denominator. In the second fraction, I have 6. 6 can be thought of as 3 times 2. We already have the factor of 3, but what we don't have is the 2. So I want to include an extra factor of 2. The final fraction contains one factor of x minus 2 in the denominator. We already have an x minus 2, so we don't have to put in anything extra. So the least common denominator that we're going to use here has a 3 times a 2, which is 6, and x minus 2. So we're going to take the entire equation, so the entire left side, we're going to multiply by 6 times x minus 2, and the entire right side by 6 times x minus 2. And then remember what that means. So on the right side, there's 2 terms. This 6 and x minus 2 gets distributed to each of the terms. So on the left side, I originally had x plus 1 over 3 times x minus 2. That's going to get multiplied by 6 times x minus 2. On the right side, I had a 5x over 6. That's going to get multiplied by 6 and x minus 2. Being added with a 1 over x minus 2, which is going to get multiplied by a 6 times x minus 2. I'm going to put 1s in all of those in case I get confused about what's in the numerator and the denominator. So remember, when you look to simplify, you're really focusing on groups. This is one group that's multiplying together. This is a group here, and this is a group here. So in this first group, the factors of x minus 2 cancel, and 3 can go into 6 but leaves a factor of 2. Okay, so there I'm left with an x plus 1 multiplying with a 2, so 2 times x plus 1. In the second group, the factor of 6 can completely factor out the other factor of 6, but I'm left with 5x times x minus 2. In the third group, the x minus 2's can completely cancel out, and I'm just left with 1 times 6. And I'm just going to clean these things up a little bit. So here I'm going to distribute the 2, 2x plus 2. Here I'm going to distribute the 5, so 5x squared minus 10x, and then 1 times 6 is 6. And then look at the type of equation you have. So in the last example, the type of equation that we had, oh, I apologize. Sorry about that. The last equation that we had in the previous example, once we got rid of the denominators, it looked like this. It was a linear equation where we could just separate y from everything else and get y alone. When we look at our equation here, this is a quadratic equation. So remember, for our quadratics, effective methods of solving them are quadratic formula and factoring. But we can't do any of those till we have it set equal to 0. So I'm going to try and move both of these terms and cancel them out, so I'll get a 0 on this side, which is fine as long as I do the same arithmetic on the other side of the equation. So I'm going to have 5x squared minus 12x plus 4. And now I'm going to hope that this is factorable. So a lot of you guys use like the method where you use this little, what's 5 times 4? Can things add up to equal negative 12? So that would be, are there two things that multiply to make positive 20 and add to make negative 12? That would work as negative 10 and negative 2. For those of you that do this factoring method, your negative 2 and your negative 10 can basically replace the negative 12. So this is just a small factoring reminder embedded in here. If I replace the negative 12 with each of those, and then I could factor by grouping. So these two terms have a common factor of x. These two terms have a common factor of 2. I'm going to take out a negative 2. And then when you look at what's left, see that this group here has a 5x minus 2 in it, and so does this one. So one factor is going to be 5x minus 2. When that gets factored out of this first term, if that's gone, you're left with x. And in the second group, if that's factored out, we're left with minus 2. And then remember, the reason that we factor it with it set equal to 0 is because that gives us options for what could equal 0. And for one of our solutions, that would give us 2 over 5. And for the other one, that would give us 2. Okay. As we go and check these, because remember, we're checking for extraneous solutions. And remember what we're really checking for. I'm going to go back up to my note. We're checking the original equation. We're specifically looking to make sure none of our answers make that 0 in the denominator that makes something undefined. So look at the denominators from this problem. The only ones that have x in them are x minus 2. Would any of our solutions here make that x minus 2 equal to 0? This one is a problem right here, because if you put in a fraction with whatever's on top, if it said x minus 2 and you replace x with 2, you have 2 minus 2, and 2 minus 2 is 0, making that undefined. So this solution has to be eliminated. You didn't do anything wrong. It's just extraneous. We have another solution, so we do still have an answer. Our answer will be 2/5. If we didn't have another answer, our answer would have been no solution. All right, and we're going to try one more for you guys. So again, the key is to have the denominators factored, okay? So this one needs to be factored here. Oops. Okay, when I take out a 2, it'll be 2r plus 1. And so the LCD I would choose for this, when I look at the first denominator, I need 2r plus 1. When I look at the next denominator, 3. When I look at this denominator, a factor of 2, and a factor of 2r plus 1. I have the 2r plus 1, but not the 2. So my least common denominator here would be 6 times 2r plus 1. Okay? So everything that was originally in my problem is going to get multiplied by 6 times 2r plus 1. And sorry, it takes a minute to set it up. If you have to, put 1s in the denominators here so you don't get confused. And then you're going to look at each chunk as far as what can be simplified. So you're looking here, here, here. So 2r plus 1 can be canceled here, and we're left with r plus 2 multiplying 6. 3 can go into 6 but leaves a factor of 2. So here we have an r multiplying a 2 multiplying 2r plus 1. Here the 2r plus 1s can cancel, and 2 goes into 6 but leaves a factor of 3. So here we have a 3 multiplying a 3. So this you're probably most common seeing as 2r instead of r2. So when I distribute each of these, I'd get 6r plus 12. Here I'd get 4r squared plus 2r, and then plus 9. And again, this is a quadratic. So I'm going to work to move all of these to the same side of the equation and see if that's factorable. So again, those of you that use this method, you'd be looking for something that multiplies to make negative 12 and adds to make negative 4. So that would be negative 6 and 2. So a couple of factoring steps here. Remember, those values are taking out that middle term. And then you can look at this group to take out a greatest common factor, and this group to take out a greatest common factor. And then when you look at what's left of these two groups, they have something in common. And when that is factored out of each of those, you have what that common factor should multiply by. Okay? And again, this gives us two possible ways to solve this. And we get negative 1/2 and positive 3 over 2. When we look back at our original problem, negative 1/2 has to be eliminated, because if we plugged that in here, that's when, if 2r plus 1 equals 0, that's negative 1/2. We'll make that equal to 0. That's an extraneous solution. So 3 over 2 is good, but not negative 1/2. So goal here, know what to multiply everything by, then go through the solving process, and then check your solutions at the end, okay? And we'll be using this when we're graphing. This is really an Algebra 2 review, but we will need to use this in graphing these types of equations.